So this is the code, the FFmpeg pipeline that we're about to see run. Just the FFmpeg part stripped out, and the actual scripts for the purpose of pulling stats and whatnot. There's a bit more on top and a bit, but this is the actual pipeline. And as I said, it was just to highlight the differences as in within an actual diff in VS Code. So if we walk through it, we're probably all familiar with a lot of this syntax already, at least the sort of main skeleton of it. And as highlighted, and the whole idea of highlighting was just to show that really it's actually just the encoders, decoders, and I guess encode parameters that change. And that's fundamentally down to using hardware frames versus software frames, right? As you can see at the top, we've got our sort of, I guess, our line one with our, we're saying, read at the native frame rate, don't accept standard input. We're going to stream loop because this is taken from the live demo. So just to loop the input. Nothing changes there. It's nothing to do with what type of frame it is. Sorry, I should have started with this. On the right side, this is the hardware, the hardware side, and on the left side, this is the software side. So yeah, okay. At line 2, we have to introduce, because this is a hardware decode. We have decode on the actual hardware. So we're locking it to the first decoder 0. So it's the same as when you specify your encoder, you get your minus CV. It's a H.264 decode of everyone's favorite clip that they've never seen before, which you'll see on line 4 on this side and line 2 on the CPU side. That's the only difference. You can see we also add a parameter for putting hardware frames out. Because we actually want hardware frames. Then we get to our filtering, and basically with some of these parameters, you can see all it really changes as we put NI quadra and then in quadra in front of some of them. That's pretty much the only difference there. As Kenneth just pointed out to me, I actually don't need the 2 0 zeros. That wasn't good, was it? I think it's the HDMI. I'm sorry. It was my laptop.
There you go.
I do apologize. Okay, I'll hold this. Okay, we actually don't need these 2 0 zeros there. It's just that we have 3 outputs of our filter, and we can access them that way. In this case, we're taking 3 outputs of the first decode. So if we move down to line 10 on this side, it sort of marries up with line 8 on that side, I think. It's where we map our different resolutions. We've got a 1080, a 720, and a 540. Again, we introduce the encode. Instead of libx265, we have a H.265 quadra enc. Again, locking it to enc0. And then we have our Xcode parameters instead of our, I guess, software CPU parameters. And that just repeats for the bottom 2 renditions as well. We're sending the top 2 renditions of the 1080p and the 720 to the null muxer for the sake of the test, and I'm hoping to show you live video. The bottom, I chose the bottom resolution. I wasn't sure of the bandwidth. So I'm actually, there's an SRT listener in the background, so this is UDP out, but we're going to pull that back by SRT. And respectively from 1080 down, it's a 5 meg, 3.5, and a 2 meg encode on each. And I've tried my hardest to match the parameters as closely as possible between each other, including the buffer size. That's got it's basically a 3-second buffer. The only difference is we specify in bits and sorry, in milliseconds, and the CPU side specifies in kilobits. Okay. Should be deliberately nothing there, I promise. And the same with that side. So I'm going to run 2 identical tests. We've got a server in Rotterdam, which we're going to use for the software side. I hope maybe that's way too small. Okay. Maybe you can see that the last part of the directory structure on the left-hand side says software, and on the right-hand side says hardware. So the left-hand side is a server in Rotterdam, and the right-hand side is a server in Montreal. And I'm on multi-exec mode, so I'm just going to run the same scripts on both. I just want to first prove that they're both identical servers with an LS CPU and the important bits pulled out. And then I'm going to run a script. I'm going to be really, I guess, cruel to us. We're going to do 20 transcodes of that 3-rung ladder. And on the CPU, I think we're going to do 10. So let's see what happens. We do get video. Struggling for space. Never thought I was struggling for space. Okay. So whilst these are running, there will be obviously different latencies. It's in line with what we expect. Montreal is a bit behind, even though I set the scripts off at the same time. You probably see already some, if you can pick it out, some frame drops on the CPU. It is a bit too much for it. It's also a H.264 decode and a H.265 encode with a small frame rate change. I will show you if I can. The differences in CPU loading, if you like, on both sides. The software side, it's doing 10 encodes. As you can see, it's not too happy. They have to put the average CPU usage down here because there's just not enough sort of real estate to show it all. You can see the FFmpeg process is running here in the process list. But yeah, it's not too happy. I wish I could keep this, yeah. You see the left side is showing all those typical artifacts of resource starvation. Okay. If I show you the Montreal side, it's I mean, nothing's running on the CPU, right? So you know, that's probably expected, but you can see all of the processes running, including the SRT listener, which is nice. Okay. What we do have instead of HTOP, if you like, is our own monitoring tool. This has 3 cards in the system, so you might have remembering back to the syntax where I said we were locking into 1 card, 0, 1, and 2. That's what you see here. We've got our decoders at the top. You've got all of the stats at the very top, sorry. Then you get a number of decoders, 3. And you can see everything's running the decode on the 0 row. There's 20 instances decoding at 20 to 30% load. On the encoders, the block below, we've got 60 instances running because it's 20 times 3. And we're at 86% load, running all of those jobs. That is pretty much, I feel like I flew through it, but that is pretty much what I wanted to demonstrate. Maybe I have to kill some processes before the CPU side falls over. So that's what I'm going to do. I do have a VOD demo to show as well after this. Okay. So that was the live demo. There's obviously, we're going to go faster than real time because we're not using the -RE flag on the VOD side, so there's not going to be no output, be it stuttery or not. This depends on not having any. If I have a line wrap, it kind of gets messy on the screen, so I'm going to reduce that size just for the sake of this demo. Hopefully it'll be there. Okay. Maybe I can zoom in a little bit. That was what I didn't want to happen. Yeah, maybe if you really want to imitate what I would do is get really close to the screen to see this. I'll set both running again. Okay. The main thing I wanted to highlight here is just, even with no line wrap, okay, we just have to look down here for the VOD side, for the hardware side, and up here for the software side. You can probably see FPS on the hardware side. We're doing 271 frames per second. It's still Big Buck Bunny, and on the software side we're sort of 52, 53 frames per second. On the software side it's going at 1.7x, and we can't see my slide because of line wrapping. But it won't be long before it finishes anyway, and we'll get a elapsed time. I happen to know there's only about 5 more seconds to wait.
It's the 10-minute clip.
This is all filler. Okay, so yeah, we did have a line wrap, so apologies. It's different screen sizes. Okay. We can wait 9 times, 9 more times the length of that. So what was that going to be? 10 minutes for the software side to complete, and we'll get roughly the same stats. Although each encoder puts out different stats, you don't get this breakdown quite with XT65. I've got I can zoom in now. Okay. I included the benchmark stuff, so although it's the same as the elapsed figure, it did that transcode, all 60 transcodes in 66.025 seconds, and dropped no frames. We got the frame breakdown, and all of the good stuff we usually rely on. I can leave that running, and we can see what happens to the software side if you like. Or we could move on and do something else.
We're a bit ahead of schedule, so we can sit here 10 minutes.
Yeah, I'd love that.